Hello everyone, welcome to the week 12 notes video. I hope you are having a wonderful day. We're going to jump right in. This video is not too long, but it is very calculator heavy, so please make sure you have your calculator ready. So back in our week 4 notes, we learned something called linear regression. What linear regression does is it takes a bunch of points that will typically make up a scatter plot in a linear pattern, and it created the line of best fit equation for that scatter plot of points. What we're going to be doing in today's video is an exponential regression. It's the same type of process in the calculator, except the pattern's going to be different. So again, when we did it before, it was when the points followed this linear pattern. In this video, the points are going to follow more of an exponential pattern. In real life, not sure if you've ever heard of anything called like something growing exponentially or decreasing exponentially. It's when it's really like increasing or decreasing quickly. So notice these points start way down here, and then all of a sudden, woo, the points get really big really fast. So that would be an exponential pattern, but you'll notice that it also curves, and that's the whole idea of an exponential function or an exponential graph. So the steps in the calculator are going to be very similar to linear regression. If you remember them from week 4, you have to click Stat, which is on the top middle. I just pressed it so you can see it's highlighted in white right now on my calculator. You'll go to Edit, and then you have to type your lists into L1 and L2. I'll walk you through that with the next example in just a second. But the big step that's different from linear regression is step 4. We're going to choose exponential regression instead of linear regression. Pretty straightforward when it's an exponential function, and the directions will tell you when it's an exponential regression or an exponential function as well. So I'll walk you through the steps on the calculator for our first example. So going to the next page, we are going to use the table below to answer the following questions. So part A says find an exponential equation. So it says that right there, exponential, that best represents the data above, using exponential regression. So it even tells you exactly what to do, and the steps will be given to you as well when needed. So then it says round your coefficients to the nearest hundredth. We'll get to that once we actually have our data. So here's the step-by-step in the calculator. You're going to press Stat on the top left, the top middle. Mine's highlighted in white right now. Then you're going to press Enter to edit your lists. Now there's a good chance you probably have numbers typed in when you did from the week 4 video. To clear your lists, you have to scroll up to L1 and then press the clear button. It's going to clear the whole list for you. If you're not using the app and you're using an actual calculator, you have to press clear enter to clear that list. But no matter what calculator version you are using, you have to be highlighted over the letter that you need to clear. So now I'm going to go over to L2. Oh, you have to hit clear enter on the app as well. I apologize. I thought it was just clear. It must be my other app. I am a math nerd and I have multiple calculator apps. So to clear the list, highlight over L2, hit clear enter. Same thing over L1, hit clear enter. So that is how it is for the real calculator and for the app, clear enter to clear those out. Okay, now when you're typing these in, it even says it on your step-by-step, you're going to type the X values into L1, Y values into L2. Now on a table, it is labeled that X is up here, but it's always going to be X on top, Y on the bottom. So that means this will be my L1, this will be my L2. Now, as you're typing these in, please make sure you're typing them in carefully. If you type in any of these numbers incorrectly, the whole thing is going to be wrong. So please be careful, especially when we have decimals like this, that you're typing in everything correctly. I would even double check when you are done. You might have just missed a button really quick. It's just not worth it. All right, so I just double checked mine. If you need more time to type them in, just pause the video real quick. I'm gonna go to the next step though. So we went Stat Edit, we already did step 1. We cleared out our lists, and then we typed our X values and Y values into our L1 and L2. My next step is to press Stat again, the same stat from the first step, but we're not gonna click Edit anymore. Right here, it's telling me to go over, hit the right arrow to go to Calc, and then you are going to scroll down until choice 0, which is exponential regression. So I'm going to go down to choice 0, and then you are just going to keep pressing enter until your answer shows up. So when I say your answer, you can kind of see it on mine right now, but it's the y equals a times b to the x, and then there's an a equals and a b equals. If your calculator or your calculator app is showing the r value as well, just know that that's not something we're going to look into for exponential regression. We talked about it for linear regression, where the closer that number is to 1, the stronger the correlation is. We're just not going to dig too into that with our exponential regression because we're going to go a different route and review something from a previous week of notes. So to recap, for showing your work for a regression question like this, because everything was done in the calculator, you have to write down what you got in the calculator to show your work. So you have to copy down y equals, a equals, and b equals. Like I said, you don't need those r values for exponential regression in this class. So I'm going to copy down everything from my calculator. Actually, I'm just going to write this a little smaller so we have some more space. If you need more time to copy down your numbers, just pause the video, but we are going to talk about rounding this now. So back in the beginning, we talked about what to round to. It says to round your coefficients to the nearest hundredth. Hundredth is 2 places after the decimal point. So for A, that would be right here, but I do have to look 1 digit after it, 5 or above, give it a shove. So that one is going to round up. So this one is going to round to 47.97. And then for B, 2 places after the decimal point would be this 4. And there's a 4 after it, which won't bump it up. So it's going to stay 0.94. Now that was the work that I needed to show, and I have now rounded my values, but that's not the answer. Your answer needs to be your final equation. So it even says that right here, and your last step, you have to substitute your values into your equation form as they're rounded. So my equation form is this right here. I need to plug my A and my B into that equation form. So my final answer will be y equals, but in place of A, I'm going to plug in 47.97. And then it's times B, so B was 0.94, and then it's raised to the x. So I bring that x down, and this is going to be my final answer. So it's a lot of calculator work. The only step that you need to do from the calculator work is round the numbers and then plug them into that y equals a times b to the x. And that's my answer for part A. Now for part B, it says to use your equation from part A to predict the temperature of water after 48 hours have elapsed. So now that we've done part A and we have our equation, we're gonna have to plug some stuff into it as like a follow-up question. So I wanna read carefully. It's giving me that I have to plug in 48 hours. When I go back up to my table, it said that hours was my x value. So it's telling me that x is 48. So what I need to do is rewrite that equation from part A, but instead of x, I'm going to plug in a 48. So it'll be 47.97 times 0.94 to the 48. I'm going to clear my calculator, and I'm just going to type that in exactly as I see it. It's 47.97 times 0.94 to the 48 gets me this number when I plug it in. And then it says to round my answer to the nearest tenth. Tenth is 1 place after the decimal point, but I do have to look at that digit after. 5 or above, give it a shove. So that 6 will bump that 4 up to a 5. And I was trying to predict the temperature. So I'm going to go back up here, and it says the temperature was in Celsius. So I'm going to write that my answer is in degrees Celsius. Now, we'll be honest, part B is a little bit easier than part C. We're going to get into it for part C here. So for part C now, it still says using the equation from part A. So I'm going to be using this equation again. I have to estimate the time x. So for this one, I'm solving for x for when the temperature of the water is at exactly 30 degrees. So look at the difference in the way that this is worded. For this one, I'm solving for x. So I'm not going to be plugging in for x like I did in part B. I leave x as is, and it's giving me that y, because y is the temperature of the water, it's giving me that y is 30 degrees. So I have to plug in 30 where I see y, because again, up in my table, y was in temperature of water degrees Celsius. So using this equation, instead of y, I'm going to plug in a 30, and then the rest of my equation is going to stay as is, including that x. I'm not plugging in for x because I'm solving for x. So now that my equation is set up, I have to solve this for x. Think back to last week's notes. When you're solving an equation that has an x up in the exponent, you have to use logs. So we're kind of connecting last week to this week. I have to use logs to solve for that x up in the exponent. Now, I can't do logs yet. If you remember from the last week's video, you can't do logs until the number that's being raised to the x is by itself. So even though these are icky decimals, I still have to follow those same steps. These numbers are being multiplied. So to get that 0.94 to the x by itself, I have to undo that by dividing by that 47.97. So that's going to cancel these out, and that's going to get me my 0.94 to the x by itself. Now, unfortunately, on the left side, I have to do 30 divided by 47.97, and I get a really long decimal. You cannot round this early. You have to bring down, even though it's annoying, the whole decimal, because each one of those digits is going to play a role in getting me the right answer. So I wrote the whole decimal. I can't round until my very, very last step. So now that I got this by itself, that 0.94 to the x, I'm able to use logs. So a quick recap on logs. Your first step is to write the word log on both sides. So I'm just going to do that and bring down this whole decimal as I do. And all I did for that step was write the word log on both sides. Now, what that log operation does is it takes my x that's up in the exponent and moves it out of the exponent so that I can now solve this. So this is still going to say log of 0.625,390,8693, but now it's going to be x log of 0.94. I believe we talked about it in the last video. You can do these two steps at once. If you wanted to do it at once, you would skip that red step and just write the word log on both sides and move the x to the front. You can totally skip that step and do them both at once if you're comfortable with that. All right, but now I'm almost done. To solve for x is being multiplied by the log of 0.94. So to solve, I have to do the opposite and divide by the log of 0.94. You don't have to know what the log of 0.94 is to know that anything that divided by itself cancels. So I got x by itself, and now I just need to do the log of that decimal, the whole decimal, a reminder, you're using that whole decimal for now, divided by the log of 0.94 gets me 7.585 and so on. If you need a second to practice plugging that in your calculator, again, pause the video, but I got my numbers, so I am going to round mine to the nearest tenth like the directions say, and it's going to be 7.8 will bump the 5 up to a 6. And remember, we were finding x in hours because my time up there is in hours. So it will take about 7.6 hours for the degrees to reach 30 degrees Celsius. Okay, so first doing that regression mostly in the calculator, and then we're just recapping stuff that we learned throughout the year, throughout the semester, where I'm plugging in numbers to evaluate and then using logs because I had to solve for x in the exponent. All right, now what we're also going to do in this video, we just have one more question, is we are going to graph exponential functions. Before we do, I am just going to give you that the code word for this video is pizza because I'm hungry. So the code word for this video is going to be pizza. Hey, make sure you write that on your quiz to get credit for watching this video. And now we're going to finish this video up with a graphing question. So we did graphing earlier in the semester as well when we were graphing quadratic functions. You just have to follow the same steps, but this is going to be a different type of function. So in your calculator, you have to go to your y equals button, and then you should always click graph to see what it looks like, but ultimately you want to press second graph to get the table and then plot as many points as you can. So what we're going to do for our first example is graph this equation, y equals 3 raised to the x. Be careful, that is very different than typing, that's very different than typing in 3x. Make sure you do 3 and then hit that caret button to go up in the exponent and then x. That caret button is right above your division symbol, right underneath the clear button. So I typed it in as 3 raised to the x, and then like I said, you should press graph to see what it's supposed to look like. Okay, I have changed my window for a previous example. You can go back to your normals 10 by 10 window by pressing zoom 6. Zoom is highlighted on mine right now as white on the top middle, and then just press 6. It'll take you back to that standard 10 by 10 window, which is what we want because That's what we're graphing. There's a good chance you were probably already in that window. I apologize. I made a previous video for a different class, and that's why my window was a little out of whack. So now that it's all back to regular with that 10 by 10 window, this is what my graph is supposed to look like. Now remember, you can't just do that. You have to actually plot the points. So to get the points, you're going to press second graph. And then we have something that we need to talk about before we start plotting the points. When you are graphing an exponential function, which just means there's an x up in the exponent, we talked about that in the last video, there's going to be something on the graph called an asymptote. So an asymptote, just the definition of it first, is a line the graph approaches but never touches. Okay, so the definition of an asymptote is a line that your graph approaches but never touches. So what that means is there's going to be a certain spot on your graph where the graph is just getting really, really close to a certain number, but it's never actually hitting that number. And you can find that on your table, which I'm going to show you now over here on the calculator. So as you're looking at your numbers, if you scroll down on your calculator table, notice the y values are going from like a 1 to a 3, then 9, then 27, 81, and our numbers are getting really big. Remember, we're trying to aim for 10 by 10, so I'm not going to be graphing any of these points where my numbers are right now. Like 2,187, clearly too big, too big, too big, too big. The first number that I'm seeing that I can graph is going to be that 2, 9. So I'm going to put that at the bottom of my table. I can also graph 1, 3. I can graph 0, 1. These are really my only nice points. After that, what I want you to recognize now, I'm just going to scroll up a little bit, is that -1 is at 0.3 repeating. -2 is at 0.1 repeating. I would not expect you to graph 0.1. I just want you to see where this is going. As you keep going up in the table, watch your numbers. It goes from 0.03, 0.01, 0.004, 0.001, 0.0004. See how we're just getting really, really, really small. I want to disregard that one that I'm on right now. Just pay attention to this, that 0.000, 0.0001. We just kept getting smaller and smaller and smaller as we were getting closer and closer to 0. So as the table goes up, it is getting closer and closer to 0. That 0, because that was the number that my graph or my table kept getting close to, but never hit, is telling me that 0 is my asymptote. So my asymptote is going to be at a y equals 0, which I'll show you how to graph in just a second. But it's y equals 0 because, again, if you look at the table, it's going 0.004, 0.001, 0.000, 0.000, and it just keeps getting really, really close to 0 without ever actually turning into 0. Now, I know it's a little weird. Just trust for a second. When you keep going up, these numbers are like 5 and 1. Like, what the heck is going on with that? When you look at the bottom of my table, like I can't really show you, but see where it says underneath the bottom of the table, still on the screen, y1 equals 5.0805263425e -5. What that e means, I'm just going to write it out here because I can't write it on my calculator to show you. Just give me 1 second. It's just a little bit easier if you see it written. Okay, and then it's e to the -5. That e is scientific notation, if you are familiar with that, but it's telling you that this number is too small to not be written without that e. But that e means that the decimal point is moving left 5 spots because it's a -5. That's what's telling me it's moving left. So if I move my decimal point left 1, 2, 3, 4, 5 spots, what's going to happen here is my decimal point is here, and all of these are going to be filled in with 0. So this number is 0.0000508 and so on. So even though it looks like it's a 5, when you look deeper at that e, it's just telling you the number's getting, again, just closer and closer to 0 without ever actually turning into 0. As I go up more and more, see how this one says e -8. That means the decimal point's moving left 8 spots, and it's just even smaller and smaller and smaller without actually turning into 0. So all of that to say, our table was getting really close to 0, and that means we have to graph our line through y equals 0. So my y value is 0 right here. I'm going to draw a line through y equals 0, and that is going to be my asymptote. You have to draw that line in to get full credit on a graph like this, on a question like this, I should say. After you have that asymptote graphed, all you have to do next is plot the nice points. So I'm going to plot those points. 0, 1 is right here. 1, 3 means I go right 1, up 3. And then 2, 9 means right 2, up 9. Now, when you connect these, I want you to remember what the actual graph looked like. It doesn't go down through the asymptote. See how on my graph it's going like this? And then it, again, think about that definition. The graph gets close to the asymptote, but it can't touch it. So it's just going to kind of like ride along the asymptote without ever hitting the asymptote. If your asymptote touches that, if your graph touches that asymptote, you will lose credit. Your graph and asymptote can't touch. It's the definition of an asymptote, so it would be incorrect if your graph is touching the asymptote. And that's how you graph it. So the rest of it is plotting the points, but it's finding that asymptote that's a little bit tricky. So use the homework to practice a couple of them, and you should be good to go. So if you have questions, please reach out to me. I'm more than happy to help you, but that is the end of this video. Don't forget that the code word was pizza. Have a great day.